Hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So today we will be solving the third problem from the Trie's playlist, that is complete string. Now what does the problem state? The problem states that you'll be given an array of strings and you have to find the complete string. Now what is the definition of complete string? Let's read it out. A string is called a complete string if every prefix, if every prefix of the string is also present in the array A. Now Ninja is challenged to find the longest complete string in the array A. Now remember one thing, if there are multiple strings with the same length, return the lexicographically smallest one, and if no string exists, then you have to return the none. Okay, so you have to find the longest one, and if there are like multiple longest strings for which all the prefixes exist, then you have to return the lexicographical smaller one. So let's take a quick example in order to understand. So over here we are given this particular array. Okay, so over here we can say that Ninja is the string for which all the prefixes are there. Like for Ninja, the first prefix is n. This is the n which is already there. The second prefix is ni, which is again already there. The next prefix is nin of ninja, which is there. Then ninj, which is there. The ninja is itself. So I can say ninja is the word for which all the prefixes are there. If I come to the second example, I can say that there is no string whose all prefixes are there. Hence, I will return none. So that is the question, and we have to solve this. Okay. So in order to solve this problem, the prerequisites are lecture 1 and lecture 2 of this particular Trie playlist. This is an absolute must. So if you haven't seen it, please make sure you watch it before checking out with this video. Okay. So assuming you have seen that, now the question says you have to find the string which has all the prefixes. Okay, with all prefixes. Now what is my initial thought process? How should I do this? This is something like, what if my Trie contains all the words? Okay, makes sense. What if my Trie contains n, ninj, ninj, nin, ninja? What if my Trie contains all the array of strings? Okay, if it, then what I can do is I can insert all of them into a Trie. So once I've inserted all of them into a Trie, then I can go word by word. So the first one, n, whenever I go, I'll say, okay, n does exist in the Trie. Hence, this can be a complete string. Next, when I go to ninja, it will be like, okay, n exist, ni exist, nin exist, ninj exist, ninj exist. So thereby, this can also be a complete string. Correct? That is what I can. Now, if this can be a complete string, I'll be like, okay, this is the longest that is possible. So in this way, I can go across all the strings and check. Like for ninja, when I check n exists, I exist, nin exists, but ning doesn't exist. Hence, this cannot be a complete string. So out of all the strings, this is the only particular string which is complete. Hence, I can print it. So quite easy. What I do is I insert all the words, then I just reiterate and check if the word, like all the prefixes of the word exist or not. So that is how we will be doing this. Again, we have to store words, and if you remember our first lecture, we just need a Trie data structure which will be having an array of size 26 which contains all the links, and we will be having a boolean flag which makes sure that it is marked as true if the word ends at that particular character. That is what we will be requiring. So let's get started. Now, whenever we start with Trie, what is the first thing that we always take? We take the root of the Trie, correct? So let's take the root of the Trie, and we can be like, okay, flag is marked initially as false. So let's take flag as false. So this is what I've taken, flag as false. Now let's try to insert all the words one by one. The first word is n, which has to be inserted. So this is the array of size 26, correct? Do we have an n over here? We don't have. So what we do is we insert n with a dummy Trie. Yes, we insert n with a dummy Trie, and the f initially marked as false. Yes, with the F initially marked as false. Now what's my next step? Next step is the word N is completed. And if the word N is completed, I can say, if I've inserted N, I'll be standing over here. This is the last try where I'll be standing. So it's time that I will be replacing this flag as true. Yes, so let's replace the flag as true. So we have inserted N. Now let's do the next one, which is NINJA. Let's try it out. Do we have N? Yes, we have an N. Let's move to the try of N. So we have moved to the try of N. Do we have I? No, I don't have an I. So please insert I and have a corresponding try to it. So please have a corresponding try where the flag is false. Yes, where the flag is false. Now we are standing over here. Do we have an N? No. So please have an N and have a corresponding try to it. So just have an N and have a corresponding try to it. Perfect. Next we will be standing over here. Do we have this J? No, we don't have this J. So kindly have this J and have a corresponding try to this particular J. Next, do we have this particular A? No, we don't have, and we are currently standing here, so we do not have an A. So please take that A and have the corresponding try to it. So I'll have this corresponding try like this. So at the end I'll be standing over here. Yes, at the end I'll be standing over here where I can say that all the alphabets have been inserted. Once all the alphabets have been inserted, you go to the last wherever you are standing and you make sure that that is marked as true. So the flag will be marked as true. So remember, this is where you end up with, and this is where you can mark the flag as true. Okay. So we have made sure that NINJA has been successfully inserted. Next, it's time for NINJ. So let's try to insert that. Well, take NINJ. The first one that I'll get is N. So we are standing at the root of the tree. So we start with the root of the tree. Correct? And we see that something like N does exist. So let's go to the corresponding try. So what I'll do is I'll go to the corresponding try. Now once I go to the corresponding try, does I exist? Yes. Go to the corresponding try. Does N exist? Yes. Go to the corresponding try. Does J exist? Yes. Go to the corresponding try. Now remember, for J, this is the corresponding try. This is very important to understand. For J, this is the corresponding try. So I can say that I have successfully inserted NINJ. Thereby, the last one wherever I was standing, for J I was standing here. I'll go over here and I'll mark this. I'll mark this as true. Yes, I'll mark this flag as true. So I can say NINJ has also been inserted. Similarly, you can do for NI. For N, you can say N is over here. I is over here. So for I, this is the reference try. Thereby marking this as true. So NI is also inserted. Next, NIN. So let's try that out. NIN. So first, N is already there. I is already there. Next, N is already there. Correct? So for N, this is the corresponding try. So please mark it as true. This is also done. Next one, NINGA. So N, I, N. Do we have a G? Do we have a G? No, we have a J. So what you'll do is, you will insert a G and you'll create the corresponding try for that G with flag equal to false. So for G, you will be standing over here. Yes, for G, you will be standing over here. It's time to insert A. Please insert A and have a corresponding try for that where the flag will be false. Now, can I say NINGA has been inserted? I can definitely say that NINGA has been inserted. What's the last task? Just make sure the flag is marked as true. Since for A, this is the corresponding try, flag is marked as true. Remember one thing for sure, if this is N, the corresponding try for N is this. It's the reference try that you will always be using. Okay, so what we have done is we have made sure all of them are inserted. All of them are inserted. Now it's time to check if, which is the longest complete string. Let's start with N. N. Is it true? Yes, it is. It is. So n can be a complete string. So as of now, my complete string is n. Okay, next, let's go to ninja, that is ninja. Does n exist? Yes. Is it marked as true? Which means there is a word that ends with n. Okay, next, I. Does I exist? Yes. Does the reference trie have a true? Yes, which means there is a word that ends with ni. So now we are standing at this particular trie. Does n exist? Yes. Does it have true? Yes. Which means there is something like nin. This prefix is there. Okay. Next, there is j. Does j exist? Yes. The prefix is also marked as true, which means there is also something as ninj. There is also something as ninj. Next, does a exist? Yes. Is the prefix marked as true? Yes. So that means that there is something as ninja. Since for every character the trie is containing true, 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 which means all the prefixes do exist. Hence I can say ninj can be a complete string, and this is the longest. Similarly, you can check for ninj, which is again a complete string, but it is not the longest. Next, ni is again a complete string, but not the longest. Next, nin is again a complete string, but not the longest. Next, ninga is a complete string, is it? Yes, no, it is not. Let's see how. Because if you start with n does exist. So n exists. Next, I. For I, that exists. So ni also exists. Next, n. For n, this is the trie, so true. So nin also exists. G. For G, this is the trie. Over here it says false. False, which means ning doesn't exist. So this is not a complete string. Thereby I cannot term this as a complete string. So the longest common string is ninja. This is how you can solve this particular problem. Okay. So let's discuss the time complexity and space complexity once. Now if I ask you the time complexity, what's the time complexity? I'm trying to insert all the strings. So if the array contains n and the average length of all the strings is len, can I say I'll definitely take n strings, and for every string I'm taking length time to insert it. That is perfectly okay. Now what about the space complexity? Now this is kind of tricky. In tries, generally we cannot predict the space complexity. Why? Because the first root might contain A, B, C till Z, all 26 tries, and everyone will have a reference trie, and those reference trie will again have something like this. Again 26, guys. So it's going to be 26. For every 26, it's another 26. Correct? So that becomes 26, 26. Now for these 26, it's again 26. Now for these 26, it might be again 26. If I'm taking the worst case, it will go up to till 26, 26, 26 into 26 till you can have the string lengths. That generally doesn't happen, because as we see, if there is a repeat of word, yes, if there is a repeat of word, it tends to use the same trie. Thereby, we cannot exactly predict the space complexity, but I hope you understood how the space complexity works. Generally, in trie, we bother about the time complexity because we get it done in a way faster time. Like we just do everything in bgo of length for a particular string. So by the way, the time complexity was bgo of n into n to insert, and another bgo of n into length in order to check if that guy is a complete string or not. I hope that makes absolute sense for time complexity and the space complexity. Now it's time to check out the C++ as well as the Java code, and I'll be coding it live. So let's check it out. So as usual, the C++ code is on the left and the Java code is on the right, and I've already pre-written the Java code because I cannot code it like all the codes twice. So let's get started. So you'll be basically given the length of the array and the vector of strings. So what do you need to do? You need to create a trie. That's the first step. So that's the first step. So let's create it. Struct of try. What do you need? A node, a star, links of size 26, and a boolean flag, which is initially false. In this try, what do you require if you think on a longer run? You need something which is like contains key, which you have already done. So let's write the contains a key, something like character ch, and you can directly say if it exists or not, like links ch minus a. Now this is basically where I say a is represented by 0, b is represented by 1, c is represented by 2, and so on, like z is represented by 35. So if you do ch minus a, it will give you the ASCII, corresponding ASCII of that particular stuff. So that is how you can do a contains key. What's the next thing? I can say the next thing is, by the way, we can just have it as node. What is the next thing? The next thing is we can like node star get, where we say that give me this character. For this, give me the reference try. So can I say the reference try is quite easy, like ch minus a. Okay. What can be the next thing? The next thing can be, let's assume that there is no reference try for this guy. So character ch, and we'll be given a new node, new reference try, and we will be like, okay, so what can we do? We can easily say the links of this current one, yes, the links of this current one will be like keeping this new reference try. That's very simple. And at the end, I can say boolean, void set end. So we can have like void set end, where we say, okay, for this guy, flag equal to true. So this is what you can do. And we can have boolean is end, something like boolean is end, where you can return the flag stating key if it is. This is the standard try that we use. So I've written all the functions that are required. Now what do we require? We require a class try. If there is a struct node, we require a class try, that's for sure. So let's declare the class try. In this class try, we know one thing for sure, that there will always be a constructor. So let's have a constructor. One other thing that I'm sure is, like I'll also scroll down the Java. The other thing that I'm sure is, I will be requiring one root, correct? So let's have the root, we can call it as the root. Whenever someone creates an object of this particular try, we know that we will be requiring a new try. So let's create a new try. What do we require? We require the insert function. If I speak logically, we require the insert function. Again, let's keep the insert functions right over here. Let's have the insert. So for insert, they'll be giving you the string word which you have to insert, correct? So I can say initially, to start off with, I will have the root. So initially I standard root. Now I have to insert this particular guy. So can I say I'll iterate across this word? So let's iterate across the word, which can be length or size, whatever you wish to. And then I can be like, okay, if this word is contained, does this node contains this particular word, like character? If it contains, then it is okay. But if it doesn't contains, then I have to put it across to a new try. So I can be like, okay, node dot put that you have written. Can you just take this word I and put it into a new node? I'll be like, that's correct. I definitely can do that. And if I can do that, yes, if I can do that, what's the next step? The next step is quite simple. Once I've done this, I move to the reference try, which is node dot get. So by the way, if you're writing C++, my Java, I was writing kind of Java, be like this, and yeah, this. Node dot get the reference try for this guy. So you'll get this, and node will move over here. So once you have inserted everyone, yes, once you have inserted everyone, you can simply go and boolean mark it, yes, set end. Set end is what you can easily do. This will make sure the insert has been easily set. So that's how you set the insert. Okay, done. Now let's quickly write this. So try, this is the object that's created. So if I just scroll over here, yeah, that's a Java one. So you have inserted. Now let's go across something like this one. Now I'm going across this, and I'll say, okay, try, can you please insert the IT? Now remember, it's kind of a better if you apply the try class, because that is how you write production level code. If you're writing like this in an interview, the interview will be very impressed, rather than just writing inserts. That will not look good. Rather, create an entire try class so that objects can be created, then create an object, then that object dot insert. That is how you generally code in an interview, and this is how you should code. Okay, so I've inserted everything. What's the next thing? I need to find the longest, correct? So initial longest we can keep it as null. Okay, we can keep it as null, and at the end of the day, if the longest is still null, that means we did not find anyone, we can return a null. As simple as that. Or else we iterate across everyone as usual. So iterate across everyone as usual, and you'll be like, okay, let's check if this is possible. If all the prefix exists, like check if prefix exists. So we can keep it like this, and we can send across this particular I. If all the prefix do exist, if all the prefix do exist, then what can be the case? I'll have to check if this guy is the longest guy. It will be like it.length, is this greater than the previous guy? If that's the case, then I can be like, okay, then the longest will be equal to it. Else if, what will be the other case? The other case can be the equal, correct? If they equal and they have to be greater, and it's lexicographically, I need the smallest, by the way. If it is lexicographically smallest, like over this case, compared to, in Java it's like compared to, because if it's smaller it will give you like 0. So what you'll write is longest equal to it. Written. Now I think this is fair bit of the code. Now you just have to write the check if prefix exists. So again, you can create a public function where you say boolean check. I can also keep the Java over here just to give you a better idea. Yes, check if prefix exists, and you can have the string word. Yes, you can have the string word. Now what you will do is you'll be like, okay, I have the string word. Now what do I need? I need a boolean flag for sure. Probably flag equal to true. What's the other thing that I need? I need to start off with the root, so we can keep as the root, correct? I can traverse back. Yes, I can traverse back to something like word dot length and I plus plus. Now what I need is, if this node contains this particular word, that's very important. If it contains this particular word, if it contains this particular word, what will I say? I'll be like, okay, it does contain. But if it doesn't contain, that means it's a false. Correct? If it contains, the flag has to be true. Before I go to the reference try at first. So let's go to the reference try, which is something like, again I'm messing it dot and start. So dot get word. Let's go to the reference try, and let's say flag has to be true. So flag will be like flag, and probably I can just take a node, or you can write something as, like, you can write it as you wish. Like in over here I've done an and I've done an and probably you can just do a and FL over here, that's okay. Or else you can just write it like this. Since I've moved to the reference try, check end, like boolean whatever it is end. Is end. If that's false by any means, you can return a false. And if at the end all of them have satisfied, that means you have reached the end, and it can be true. Because if at any moment you're encountering it isn't as false, you're returning false. Or else you can simply write flag end, and you can put up and flag over here. It's your choice how you want to write the code. As long as it is working, should be fine. And at the end of the day, you can just return the longest. That should work. Yeah. At the end of the day, make sure you return the longest. This is what I've also done in the Java code. So quite easy. The insert function takes big O of length of the string, and over here n. So n into length, and again another n into length. So it's n into length on like overall. So this is how the code looks like. So guys, I hope you have understood the entire explanation as well as the code. Just in case you did, please make sure you like this video, and if you're new to this channel, do consider subscribing to us. And yes, if you haven't checked out our SD sheet yet, what are you waiting for, man? You should definitely check out the Strivus SD sheet, because that is the one which everyone is doing out, and everyone is getting a lot of success by using that particular sheet, because it covers a lot of concepts about all the data structure and algorithms. So make sure you check out the SD sheet. The link will be in the description. All the links are in the description. So do consider checking it out, and please subscribe to us. And yeah, with this, I'll be wrapping up this video. Let's meet in the next one. Bye bye. Take care.